All right. So, hello. I'm Lee Comstock. I'm 38. I've been doing hobbyist game dev for many years. This will be my first release on Steam. So, Full Spectrum Gradient. It's a puzzle game. It's kind of like Tetris Puyo Puyo, but you have blocks of different colors and you place them in like a rainbow line and then you clear them. That's the basic idea of the game. If you think the audio quality is shit, it's because I don't have a professional microphone. Okay, I'm recording this on a phone. All right. The game is set to release on March 21st, pretty soon. And this is the devlog for like basically the whole making the whole game. All right. So first off, I figured let's watch the trailer because I'm pretty happy with the trailer. So I'm gonna play it. So it starts off with basically it shows you that like okay, you place the colors to make a rainbow. Oh, when you make a full rainbow, then woof, the blocks disappear. And it said make rainbow lines. And you can make horizontal, you can make vertical, you can make diagonal rainbows. There's an endless mode. There's also this thing where partial rainbows will be cleared when you make a full rainbow. So you see like lots of tokens being cleared as soon as you make a full rainbow. You got versus mode, like one person makes a rainbow and then something weird happens on the other side. And you got play stages, so you have a world map there, you pick levels. You got numbered color tokens for like either if you're colorblind, I figured, or if you're just bad at rainbows. So then you can just go 1 through 6, although it can also go 4, 5, 6, 1, 2, 3. The game runs at 4K 60. There's a slider you can pull it up to like 300 if you want. I haven't considered that. I do not have a monitor that runs at 300. And it has colors. It has red, orange, yellow, green, blue, purple. And those are the colors. Full Spectrum Gradient out now. It's actually not out. So, oh, I'm looking at the version that says out now on Steam. It's not out yet. Okay, out March 21st. All right, so how do you play it? Well, you place these. It's kind of like Puyo Puyo Tetris. You have falling blocks. You rotate them, place them. You place them. When you make like all colors in a row, all 6 colors, horizontal, vertical, or diagonal, then they get cleared. It can start or end, like it can start or end with any color, but they have to be like in order. Does that make sense? Like if you imagine a color circle. And when you make a full color gradient, all 6 colors, all the partial gradients, so like 3 or more in a row, will also be cleared. And there's different modes. So there's the endless mode for a replay for a high score. There's stages where you pick levels on a map, and there's a versus mode where you play 2 players local, either with 1 keyboard or 2 controllers. If you want to try out a demo, and so the demo is like the basic endless mode. So just vanilla basic rules of the game. Then you've got there on the sidebar there, you got a link to the Steam store page. You got a demo there. Game is made in Raylib and Rust. Okay, we'll talk about that more. And if you are a streamer who wants a free Steam key when the game launches, feel free to get in touch. You can see my email there. I should probably contact you, but I suck at marketing, so I should probably do it. Yeah, I mean, I have gone. Well, I've gotten some streamers to check out my Steam store page. Okay, so how did I get here? Well, the game is very creative, but also very technical field. So you get into it because of the creative side, and then you end up, doing well the technical side, the technical stuff, and learning that. I started off a long time ago, like making Flash games for the browser as a hobby, and then I learned Unity, made a couple of Unity smartphone games for Android. Then, just for career purposes, got into making web apps, doing front-end web development. And now, like, that definitely, working as a front-end web developer helped me improve as a software developer. And so then going back to game dev, I've now kind of shifted to making game in Raylib instead of using a pre-made game engine. And I ended up with Rust. I tried a bunch of different languages. We'll get to that. So I really wanted to do code-driven development. That's something I got used to as a front-end web developer, and so I wanted to do that. And I also, during this time, I was watching a lot of John Blow videos, and just being influenced by that, like more low-level game dev. I tried out Godot and Haxe Heaps.io, before I discovered Raylib, and Godot, it's like Unity but less bloated. I like that. It's not really ideal for like pure code-driven development. It's better for when you're doing the whole drag and drop visual interface. And Haxe Heaps.io is kind of like Godot without the visual interface. I wasn't crazy about it. One thing I didn't like is so Haxe doesn't compile to an executable. It transpiles to other languages, and they wanted you to like write Haxe code that then transpiles into JavaScript, and then you test the game in the browser. I didn't like that. So no engine versus a pre-made game engine. So it's a bit like building a house from scratch. This is my analogy. Versus moving into a house and later finding I was built on an Indian burial ground. That's my. That's how it feels a little bit. You start using a pre-made game engine, it's great, and then, but eventually a bunch of technical issues come up as you get further. And I like having full control over the code base, knowing exactly how everything kind of works under the hood. And if you look at like doing stuff from scratch without a game engine, like when it comes to 3D rendering, animation, like animation of a character with like bones and stuff, like and lighting, shadows, all this, like it's very complex. But in 2D, tile maps, sprite sheets, they're very simple. A tile map is just rendering different parts of a texture on different parts of the screen. Sprite sheet animation is basically the same thing, just that you're rendering different parts of a texture over time. These are not, especially if you have something like Raylib, a pre-made rendering library that handles the renderings, like being able to render textures on the screen so you don't have to write like 500 lines of OpenGL. Then building your own tile maps and sprite sheets is pretty simple. So you don't really need a pre-made game engine just to be able to make a 2D game that has tile maps and sprite sheets. So how did I get? Eventually I discovered Raylib. It's a C game dev rendering library. It has 60 plus language bindings, so you can basically use it with whatever language you want. So I decided to try out languages that are statically typed, because I think that helps a lot with just being able to know what the hell is going on in your code base, being able to refactor your code without where it will actually, like the compiler will actually tell you where things are not correct and you have to fix it. Not overly OP. I don't like the like unnecessary amounts of boilerplate if you're like forced to like wrap everything in classes and all that stuff. And I avoided manual memory management languages simply because I don't have experience with it. And so I figured, well, if I have to use a manual memory language, I will do that, but I'll exhaust my other options first, just to see if there are, if I don't have to do that, then so I started with trying out Raylib with JavaScript, TypeScript, because that's what I was used to from a front-end web development. The problem there is that the code doesn't compile. So, you can go into the code and make changes to the code as an end user. Haxe. So Haxe, again, doesn't compile to executable. It transpiles into other languages. In this case, it was transpiling to C++. but it actually generated invalid C++ at one point, like in just me just doing a little test project or a little test code to just render stuff on the screen. And like when you get a compile time error and it's not in your source code, it's in the generated C++. I mean, what the hell? Yeah, come on. Dart and Swift, I found them both to be slow. Swift also slow to compile. Go was generally good, but you could tell like when the garbage collector kicks in and you have like these little slowdowns where the frame rate goes down, like. So eventually I ended up with Rust. Now, Rust is fast and powerful, but safe Rust is overly strict. I found that it was too strict. So that's why I embraced 100% unsafe Rust, because I figured why not, you know? Just use unsafe Rust, and then you can do things that you can't do in safe Rust, and that I found was workable. All right, so making a game in Raylib and Rust. So my key technical priorities is I wanted to do code-driven development. I wanted simplicity. I wanted full control over my code base, and I wanted everything to run at a stable 4K 60 performance. Why did I need unsafe Rust? So two main things, or really only two things. So the first is static mutable global state. In other words, global state, or static mutable as they call it in Rust. So being forced to pass all state as function arguments gets annoying. Being able to access and mutate any game state anywhere, very helpful. Also, I needed global mutable state for like generic callbacks. So there are various things like where I just would have like callbacks that don't necessarily know, where the callback doesn't know what type it should take of data, and where I would want to be able to just change whatever in any callback. We'll get to that. I have not looked into really entity component systems more than I looked at the Bevy website. I looked at how to do a sprite sheet animation in Bevy, and I was honestly kind of just confused, like what the fuck is going on here. And it just looked kind of over-engineered. So yeah, and then multiple mutable references or pointers. Most of the time not needed, but it's necessary for the tween system that I made. I'll talk about this more later. Okay. So Raylib, very simple at its core. It's a while loop, and in the while loop you run your update code where you change your game state, and then you run your draw code where you draw textures on the screen based on the game state. Very simple. So here we see, like, okay, here in a function main, I just wrap everything in unsafe. I wanted to say unsafe function main, but the Rust compiler didn't let me. And then you run the start code, then you get the Raylib there. A lot of things in the static mutable state, like for example hash maps, you can't initialize a hash map in the static mutable state. It's like a non-const function. So there's a fair amount of things in my static mutable state that will be like wrapped in an option. So you can just initialize it as a none value. So Raylib is one of those. So you have an option of Raylib, you unwrap that. And then you say, okay, while Raylib window should close is false, then you run the update code and then you run the draw code. Super simple. One thing with Raylib is that it is by default, the build settings are set to not use the dedicated graphics card on hybrid systems. So if you want to force Raylib to target high performance GPU on hybrid systems, you gotta make that change in the CMake settings. So even if you're not a C developer, you gotta go and just make that change in the CMake settings. So for example, if you have an integrated GPU that outputs 4K 30, you have a dedicated GPU that's for 4K 60, or maybe if you don't have this, but an end user has this, you want it to be able to target the dedicated GPU. For whatever reason, the developers of Raylib don't agree with that. So that's just, you find this like glfw use hyperpg and you set it to on instead of off. So the overall project structure, I started with like just because of Raylib being made it that you have the update code that updates the state, and then the draw code that draws based on state, and you have that run every frame. At first, it made sense to just divide the code into the update code and the draw code. But then as the code base got bigger, it made more sense to divide up the code into reusable systems and game-specific scenes, is what I found. And this was not a really a refactor. It just meant moving files around into new folders. So basically, a scene. So we can see here we have a scenes folder, and every scene has its own folder, and in every scene folder you have the update code for that scene, you have the draw code, and you have the types. The types is mostly just the constructor for the scene and a little bit of other stuff. So the way this works in the code is I have an enum called scene, and then every variant of the scene enum has its unique struct for these different scenes. So the loading scene, the title screen scene, the file select screen, etc. Yeah. And then I have a preview scene because sometimes you want to go into a scene and then back to the preview scene. So you store that. And then the systems are just reusable code for things, a bunch of things. The most important, I think, is be able to draw nested elements instead of just being able to put absolute XY coordinates. Reusable menus, saving and loading, transitions between scenes, sprite sheet animation, and the tween system. Okay, so and those are the ones I'll go through. So the drawing nested element. So basically you have an element struct with a color, texture, a bunch of other stuff that also then has inner elements. So it has a vector, as REST calls it, a vector, a dynamic length array of elements inside of it. And so then when you call draw elements, you pass in an element, and then that element can contain inner elements. And draw elements will then first draw the outer element and then recursively go through its child elements and draw all of those, using the parent element as like a parent rectangle for where it should draw it. So it draws it inside, the child element is inside the parent element, and then does that recursively so it can go any level steep. And you see here, if you look at the code here, you have, width, height, padding, gap, and align values. So you can align center, left, right, top, left, bottom, left, and basically it's inspired by React and CSS as a front-end web developer. I like kind of the data-driven markup type thing in React, and so it's basically inspired by that. And if you have some vector of elements that you want to loop through and generate an element for each one, so then you do that. So an element has elements, which is then there you want a vector of inner child elements. So then you go through, in this case, you go through the vector of menu options for the title screen in this case, and then you do a map where for every menu option you generate an element. And here you have the align flow down, which means that it'll look at the height of one element, and then the next element will be offset by that amount, and so forth. You could just offset by the index of the element as well, but yeah. We got menus, and so in menus it's basically just you have a vector of menu options. Every menu option has a callback, and then in the update code you run like the update menu function, and that'll check for inputs, like going up and down the menu or clicking, tapping space to select an option, and then when you select an option, then it'll run the correct callback for that menu option. So here, I can just initialize the menu with callbacks for all the menus, for all the menu options, and that'll work. Save and load, what should I say there? It's just stored as a save.txt file. I asked ChatGPT about just how to encrypt and decrypt, and it gave me a simple example of how to do it. Actually, it kept telling me I should download a dependency, but whatever. It's not that important if someone hacks into the save data. So save data is represented as two hash maps, one hash map with floats and one with strings. And then we have scene transitions. So basically, you run a function called switch scene that takes the scene in a variant, and then it will use the tween system that I'll talk about to just animate out the old scene and animate in the new one. And yeah, the old scene is stored in this prev scene. So if you wanted to go back, so for example, if you're playing the game and then you pause and go into settings, and then you want to go back, you want to go back to the same instance of the game. So then you go back to the previous scene. Sprite sheet animations, I mean, obviously there are all kinds of places on the web where you can find tutorials on how to do a sprite sheet animation. The one thing I want to mention here was just that I wanted everything in my codebase to be frame rate independent. And so instead of simply like moving forward one frame, instead it has a float called time since last frame, and then you increase that by the frame time, the amount of time since last frame, and then when that crosses over 1 divided by the sprite sheet frame rate, which is a global value that's like 30. So 30 frames per second. When the time since last frame crosses over the amount of time for one frame, then the current frame goes up by 1. And then you check if it's supposed to loop or not. Okay. So the tween system. I use this all over the code base. And it's basically just I wanted to be able to have an easy way to just tween any float value in my code base over time. So what you have is you have a global vector of tweens, and every tween has a start value, target value, elapsed time, how long the tween has existed for, but also the duration, how long it should take to finish, an easing function, and a callback that can run at the end. Actually, it's a closure, which in Rust, for whatever reason, is a box dynamic function once. The actual value that you change, I have that as a T32, because I call it a T32. It's a float 32, but a tween 32. And it also has a boolean for being able to stop the tween. So from the outside, you can just in the game state wherever you have this T32 value, if you just set stop to true, it'll stop the tween, even though it hasn't finished. So this requires unsafe code, unsafe Rust, because now you have multiple pointers to the same data in memory, in the game state, but then also in this vector of tweens, reporting to the same float value in memory. And so therefore, it's important that the tweens vector is emptied when you're switching between scenes to avoid unfound behavior. Or if you're just, for whatever reason, you're tweening something in the middle of a tween, that float value disappears from the game state or something. So then you stop it by just saying stop true and it'll stop. Okay, so just a little bit about how it actually figures out the tween. It's a little mathy, but I mean it's just basically you take you update all the tweens every frame. So then you add the frame time to the tween's elapsed time. If the elapsed time is still less than tween duration, okay, then the tween isn't finished. So then you figure out what is the difference between the target value and the start value, and then you set the value to the start value plus the difference, except you take the difference multiplied by a float between 0 and 1, depending on how far the tween is. So you take the elapsed time divided by duration, you're going to get a float value between 0 and 1 that starts at 0, goes to 1. So when you then take the difference multiplied by this float value 0 to 1, then you take start value plus the difference multiplied by 0, this float value between 0 and 1, then it'll go from the start value to the target value. And then it's just that you use the easing function. you take the elapsed time divided by duration, which gives you a float between 0 and 1, and then you use that, you pass that into the easing function. The easing function takes a float between 0 and 1, and then returns a new float between 0 and 1 that is eased in one way or the other. So a linear ease is just taking a float and returning the same thing. Ease in, then you multiply it by itself. So for example, if you have 0.5, and 0.5 multiplied by itself is 0.25, so it'll ease in. Ease out, well then it would be 2 minus 0.5, which is 1.5. And then when you take 1.5 multiplied by 0.5, you get 0.75, so it's easing out. All the way to cubic in out, where obviously you take the float and multiply it by 2, and if it's less than 1, well then you multiply it by itself 2 times and multiply by, okay, I don't know actually, this was ChatGPT. I don't ask me to explain the cubic in out. Okay, so Rust annoyances and tricks. So some things that annoyed me with Rust. Okay, so one is like the private public thing. So in Rust, everything is private by default and inaccessible between folders, which I found annoying, especially when you have to not only mark a struct as public, but like every field of the struct is public. So instead, I decided to just get around that by I just use the include macro in the main RS file, and that just copies over all the code into the main RS file before compilation or whatever. And that way you don't have to mark anything as public, because it's all like as if it's all in the main RS file, even though it's actually divided up in folders. Another thing is raw pointers versus references. So there's this annoying thing where the people who made Rust thought that like, oh, well, since raw pointers are unsafe, therefore we have to make it syntactically noisy to dereference a raw pointer. And as a result, they do this thing where like you have to put it in a parentheses and do an asterisk on the left. And here we have, a little like nightmare scenario. This would not happen in my code base. Like I don't have this deeply nested like raw pointers or whatever. But anyway, the point is, if you have like a raw pointer inside a raw pointer inside a raw pointer, and you want to dereference it all, you see how like you end up having to put it all in parentheses and putting all the asterisks at the beginning. It's not very readable. Compared to with references, it's just, you just use dot, outer dot, middle dot, inner dot, belly. Now, there is a way to get around this. I call it the ref to pointer to ref trick. All it is you take a reference. In this case, in this code, it's prop. You cast it as a pointer, so a mutable pointer to a T32. Then you dereference it and turn it back into a mutable reference. So you just take a reference, turn it into a pointer. Basically, when you turn it into a pointer, the Rust borrow checker says like, oh shit, like, oh, this is some power user shit, I'm gonna back off. And then you just turn it back into references. So that way you can actually have multiple references, even though the Rust documentation will say, oh, you can't have multiple, you can in fact have multiple mutable references. You just turn a reference into a pointer and then back to a reference. And then you don't have to deal with the asterisk hell bullshit, because it's annoying. This also allows you to not deal with lifetime requirements. So I don't have, everything is static mutable state in basically, I don't have any other lifetimes. It's all static lifetime. And so there's this annoying thing where, oh, if you want a struct to have a field that is a reference to another struct, then Rust wants you to say what lifetime is this other struct that you're referencing, because it wants to know that it doesn't outlive, that it wants to know that the outer struct doesn't outlive the inner, the struct that it's referencing. And so what it wants you to do is like, oh, you got to then pass that in, then that struct as a static lifetime. You got to mark with that static lifetime. And then it means that, as you can see here, like the third function then takes a static lifetime struct. So then it means that where we call the third function there, in the second function, we have to know that that's taking a static lifetime struct. And so that means then the first function there, we also need to know that that's a static lifetime. So it kind of just bleeds out. And so instead, what you can just do to get around that is you just say, okay, so here we have some struct, it has a reference, and then we just take the reference to data here, we turn it into a pointer, cast it as a pointer, and then we just dereference that and turn it back into a reference. And that way you just get the Rust compiler feedback. All right. I should talk a little bit about stuff that isn't code related. So I've mostly been using Blender for my art, and so when you're making Blender art for a 2D game, well then you don't actually have to like texture it in 3D. What you can do is you just render it untextured and then you paint over it with the layer mask. You paint over it so you're only painting over the actual opaque pixels, not the transparency. This, of course, maybe isn't good for like if you have an animated character. If you're animating a character in Blender and then exporting that out as a PNG sequence, turning it into a sprite sheet, something like that, then you probably want to texture the actual 3D model. But if it's a still image, you don't have to go through all the hassle of actually texturing the 3D model itself. You can just render it untextured and then paint over it. Music, so half the music is made by my dad. So everything else is made by me, but half the music is made by my dad. And I made the other half the music in FL Studio. FL Studio, you get a cheap permanent license at €100, not, some monthly subscription bullshit. I'm a beginner at it, but I think I managed to create some cool tracks. The music in the trailer is made by me, and I was pretty happy with it. So, what will I do differently next time? So, I do feel like I'm not really in line with the kind of the ideological, philosophical views of the Rust language. And therefore, I feel I probably should switch to more of a modern C alternative, like Zig, Odin, Jai. I get the sense that manual memory management is actually not as hard as some might think. And I feel like maybe the Rust borrow checker may just be one more abstraction layer for me to shed, like going from making a game in a big bloated engine like Unity to not making a whole game, but experimenting a bit with Godot, which is more of a lightweight engine, to using Raylib, which is not even a game engine at all, just a rendering library, but now feeling like going from like some more, higher abstraction layer language like Rust with the whole borrow checker bullshit, to going to more of one of these lower level manual memory managed languages like Zig or Odin Jai. I wrote Jai beta there because I am not in the Jai beta, and this is my call out to John to you just I don't know, drop a comment. No, if you have an email that you send out to everyone that is in the invite, how about you send me that? Otherwise, I will email you. Okay. Because I wanna try out Jai. All right. What else? So I'll try to then port over my reusable systems that I would like to reuse for my next game. I will try to port them out try to port them over to whatever Rust from Rust to Zig, Odin, Jai, just to try them out, and then that way I can try out these different languages without fully committing to them. And then, make a decision based on that experience. I can make a decision of what I prefer here, and then I'll have a good starting point for my next project. I do want to implement hot reload. Like, one annoying thing of making this game was like setting XY with height on some texture, having to reload the whole game with all the assets just to see the difference, and then like change it a little bit and then reload it. And yeah. I have not found that I have an issue with like the Rust compilation time, but I do find that asset loading can take quite a while. Maybe that's because I don't have any fancy like resource packing or texture streaming or I don't do like scene-based asset loading. I just load in all the assets in just a very standard way at the beginning of the game. And it does take it takes less than a minute, but like it does slow down iteration time. So I found I did not have an issue with the Rust compile time, but having to reload all the assets every time you want to just move a texture a little bit and see if it's placed right is annoying. So I definitely want to try implementing hot reload, where I can just do this stuff without reloading the game. It's also like if you look at front end web development, you have that there, and it helps a lot. Um, I haven't really looked into exactly how you do this, but I think it's basically you have an executable that reloads a DLL library at runtime. So you have your code divided up into an executable and DLL. That's how I understand. I think it's something. I want to learn some more Blender features. So this game, most of the art is made in Blender, but I don't. I don't really have any character animation. Like all the animation actually, well, it's either programmatical or I have a 2D animation for the explosions when you clear tokens. So I would like to learn like character animation. I've done in the past character animation in Maya, but I would like to learn character animation in Blender. I'd like to learn more about shaders. That seems cool. Probably a bunch of other stuff that I look at. And finally, also better marketing. So that means, I think you really need to do continuous marketing, not just at the end of development. That's probably was pretty stupid. Just to make the game without, posting anything about it online, and then when you're basically done with it, then you're posting a trailer and a devlog. It's probably not what you should be doing. I also missed the Steam Next Fix because, well, I wasn't actually planning to have a demo for the game, and but then I figured I should, and also I hardly knew what the Steam Next Fest was and when it was. So by the time I figured out that what this even was a little bit too late. And also, my next game should probably be a more commercially viable game concept. I think probably more action-oriented, less of a weird, confusing puzzle game, as I say. Because I do think that, well, I know puzzle games are hard to sell on Steam, and also, I think, I don't know, when, the people I've seen watch the trailer for the first time are maybe a bit confused by it, and maybe that's a bad thing. So I think maybe less of a confusing, weird puzzle game, and more of a little bit action-oriented, something like that. Yeah, I mean, I know I have a pretty good idea of what my next game will be, but I'm not going to talk too much about that. So yeah, thanks for listening. Maybe you learned something. Maybe you found it interesting. All right, that's it. Bye bye.